Okay, so for this video, we will be discussing discontinuity and particularly graphing and showing the discontinuity of a function. So example, so graph the given function and determine the x-axis location of any discontinuity. So we know that discontinuity of a function happens when we have a point that is indeterminate. Okay, so particularly a value of the x-axis that will give our function a value of an undetermined value. Okay, so we have example. So f of x is equal to x squared minus 5x plus 6 all over x minus 3. Okay, so for this problem, okay, so we can see that it's fractional. Okay, so whenever we have a fractional function, okay, so discontinuity happens when the value of the denominator becomes 0. Okay, so we have discontinuity at x minus 3 is equal to 0. Okay, so that's how simple it is. So if our denominator becomes 0, then this whole expression becomes indeterminate. Okay, so if x minus 3 is equal to 0, so then our discontinuity happens at x is equal to 3. Okay, so at x is equal to 3, the function, the denominator becomes 3 minus 3, therefore it will become 0. No matter what the numerator is, as long as the denominator is 0, it's indeterminate. Okay, so in graphing this, so as you can observe, we can simplify the function. Okay, so if we evaluate its limit, then we can get a value for the limit. Okay, so let's have f of 3, function of 3 is equal to just substitute x is equal to 3, so we have 3 squared minus 5 times 3 plus 6 over 3 minus 3. Okay, so we have here 9 minus 15 plus 6, 9 plus 6, 15, so we have 0 over 0, so this is undefined. Okay, so that's the discontinuity. However, the limit of f of x as x approaches 3 is equal to the limit of x squared minus 5x plus 6 over x minus 3 as x approaches to 3. So as you can see, we can simplify the function using factoring. So this will become limit of, we have here this, we can factor this as x minus 2 and x minus 3, and the denominator x minus 3 as x approaches to 3. So we can cancel out x minus 3, then substituting the limit, so it will become 3 minus 2, so this will become 1. Okay, so the value of the function at x is equal to 3 is undefined. However, its limit approaches to 1. Okay, as x approaches to 3, the limit of the function approaches to 1. So the next step is, how do we graph this? Okay, so the simplified form of the function is this one, x minus 2. Okay, so all we need to do is graph, okay, y is equal to x minus 2. So that will become a straight line with a slope of positive 1 and a y-intercept of negative 2, right? So from your analytic geometry, so this is our f of x, this is our x. Okay, so the line is we have 1 2. Okay, so it's f of x. Let's plot f of x is equal to x minus 2. So that should be a straight line with a slope of 1 and the y-intercept is negative 2. So we have 1 2 3. It says that it approaches to 3. However, okay, so when drawing the line, we know that the value of the function is undefined at x is equal to 3, right? Then this is negative 2. So it's undefined at x is equal to 3, but its limit approaches to 1. So therefore, we have here a removable discontinuity. So we write we draw a hole, okay, in the function, okay, in the graph, I mean. Okay, so this is now a hole. Okay, so that is discontinuous at x is equal to 3. So simply, so this is now the graph of the function showing a removable discontinuity. Okay, so where this is f of x is equal to the whole function x squared minus 5x plus 6 over x minus 3. Okay, so that's how we graph discontinuous functions. Okay, so at the point of discontinuity, so we write a we draw a hole, okay, or an open dot. Okay, so that's it. So let's try another example. Okay, so let's try this another problem. So we have f of x is equal to, we have negative x minus 1 over x squared plus 2x minus 3. Okay, so again, our discontinuity will happen if our discontinuity will happen at the denominator equals 0. Okay, so discontinuity at x squared plus 2x minus 3 is equal to 0. Okay, so next what we need to do is solve for the roots. So the roots, we factor this one. So this is x minus 1 and x plus 3. Okay, is equal to 0. Equate the factors to 0. So it will become x minus 1 is equal to 0. And x plus 3 is equal to 0. So now x is equal to positive 1 and x is equal to negative 3. Okay, so those are our discontinuities. Okay, and then next we will evaluate the limit, okay, at each. Okay, so even if you try it by yourselves, so if we substitute x is equal to 1 in the function and x is equal to negative 3, then this function will become indeterminate. Okay, so what we do next is we will evaluate the limit of negative x minus 1 over x squared plus 2x minus 3 at x approaches to 1 and at x approaches to negative 3. So at x approaches to 1, we can simplify. I think we can factor out the denominator, the limit of negative. So factoring the denominator, numerator is x minus 1, denominator is x minus 1 and x plus 3. Okay, so we can cancel this out. So at x approaches to 1, so this will become negative 1 over 1 plus 3, so this is 1/4, negative 1/4. Okay, on the other hand, the limit as x approaches to negative 3, okay, so we know that we can simplify this into this, so therefore let's just rewrite it all over. So x minus 1 over x squared plus 2x minus 3 is equal to, so we can know that we can simplify it with this, so therefore we can write directly negative 1 over x plus 3, so that's negative 3 plus 3, so it will become negative 1 over 0, then its value approaches to, its value should approach to infinity. Okay, so actually we don't know if it's positive or negative infinity. Okay, so those are the values of the limits. Okay, so for graphing, like what we did earlier in the first example, so we only graph the simplified form of the function, which is this one. So f of x is equal to negative 1 over x plus 3. Okay, so now you should be familiar with the graphs. Okay, so if we have f of x is equal to 1 over x, okay, so its graph should look like this. Okay, okay, so if we have 1 over x, however here it's displaced, the infinite discontinuity, the location of the infinite discontinuity is displaced by 3. Okay, so therefore we just move the location of the infinite discontinuity. So this is x, this is f of x, so this is positive, right? 1 over x. So if it's negative, then it's the same, okay, but the only difference is that it's mirrored. Okay, so if we have f of x, so if we have f of x is equal to negative 1 over x, then its graph will look like mirrored version of this, so it will become like this. Okay, so again, since we are displaced, the location of 0 denominator is displaced by 3, then the location of the infinite discontinuity is at x is equal to negative 3, right? So therefore we will have negative 1, negative 2, negative 3. So the location of the infinite discontinuity will be here. Okay, at x is equal to negative 3. Okay, so the curve will look like this and that. So it will become, oops, yeah, so like that. Okay, and then the other one is like that. But we should take note of the uh, removable discontinuity at x is equal to 1. Okay, so its limit approaches to negative 1/4. So let's say that it's located here. Okay, the removable discontinuity. Then the graph should look like this. Okay, so we have here the graph of that function showing the infinite discontinuity here. So this is infinite discontinuity, and then this one is removable. Okay, so you should be familiar with with the curves. Okay, so you don't need to plot it using exact coordinates. Okay, so all you need to do is have a general picture, okay, of the curve. Okay, so I hope that will help you for your examination tomorrow. So good luck.